Okay, so this is Unit 1, Lesson 5B for 8th grade. I'm Mr. Zuckerbrow, doing another video. So we're picking up where we left off in Lesson 5A. Lesson 5A, we did angles with triangles, and then we also did angle relationships with intersecting lines. So we're going to add on to that in a little bit. There's two very big things we need to take away in this lesson. You need to be able to find missing angles. That's the big one, but really, number two, you need to learn and use a bunch of new vocabulary. So it's two things. It's one, you need to be able to do the math, but two, you need to be able to understand why we're doing the math, and unfortunately in this lesson that means a lot of vocabulary. So here's a do now. You need to find a measure of x. It's a multiple choice question. I would pause the video, try it on your own, see if you know how to do it, because if you don't know how to do it, then that means Lesson 5A you haven't mastered. And now we're going to move on to a whole bunch of new stuff, and you don't have it mastered. And then Lesson 6 is going to add on to both of these lessons. So if you can't do this do now, you need to reach out to your teachers and ask for extra help sessions, or really need to ask questions in those live Google Meet or Zoom sessions. Alright, so at this point, hopefully you've tried it and you're unpaused now. So I notice there's a triangle given. We are looking for one of the angles of the triangle, and we are given an exterior angle. I know this is an exterior angle because it is outside of the triangle. So there's two ways to do it. I'll show you both. One way is called the exterior angle theorem, and that states that an exterior angle is equal to the sum of the two inside angles that are not touching it. So nothing with this one right here, but the other two. So 105 equals 65 plus x. So I just have to figure out what that x is, and I do that by doing 105 minus 65, so x comes out to 40. That's one way of doing it, but I know that a lot of students don't love doing it this way and don't remember this way. Like, you might remember it right now, but you might not remember it, months from now when you have to take a state exam or a final or a midterm. So here's the other way. This is the one students most remember. The exterior angle and the angle next to it add up to 180, and the reason is because these two angles create a straight line. I also show my students, and I know I showed it in the first video, that I like to draw those angle markings. So like this 105 degree angle goes from here to here, because the angle is the space in between two lines. And I know that this angle, the one next to it, goes from here to there. And that creates a perfect semicircle. And semicircles and straight lines are 180. So 180 minus 105 is 75. So that means this angle right here is 75. And now I know that the three angles of a triangle add up to 180. So I can do 75. So we're done with this. I can do 75 plus 65. And I get 140. And then 180 minus 140 is 40. So that's two ways to do this problem. Hopefully you were able to do it relatively easily and quickly, but if not, you need to review this stuff. So here's another question. This is similar to one that we did in the in 5A. Pause the video, try it. When you unpause it, I'll go over it. Okay, so at this point, hopefully you already did it, and now you're just watching to make sure that you have it correct. So we can actually do the same two ways that we did on the previous question. So we are given an exterior angle, and we know that an exterior angle equals the sum of the two angles that are not next to it. So x plus 90, because it's a little box, equals 124. So that's one way to do it. Another way to do it is to figure out this angle next to the 124, because then we can just deal with the three angles of the triangle. So I know that this angle and the one next to it create a semicircle. I know it's a semicircle because it makes that perfect straight line at the bottom. So 180 minus 124 gives me this missing angle, which is 56. And then I can just use the three angles of a triangle add up to 180 to figure out x, which comes out to 34 degrees. Okay, jumping into it. So on this screen, what do you see? This is not in your notes, by the way. I just created this slide, but that's okay. You could draw it or just watch. What do you see? What kind of lines? What's the relationship between these two lines? Hopefully you're thinking of a vocabulary word that we covered in the last first part of this lesson in 5A. These are parallel lines. I know they're parallel because they are always the same distance apart. They will never touch. If I extend them forever, they will never touch, cross, intersect. They're always going to be the same distance apart. So these are parallel lines. That's what we're going to be dealing with all lesson now. If I was to draw a third line that intersected them, so if you can see where I'm moving my mouse, if I drew a third line, how many angles would that create? Because in the previous lesson, we had diagrams like this, where there were two intersecting lines, and it created 4 angles. So how many angles do you think this would create if I drew a line through it, like this one? Well, hopefully you are counting and thinking of a number, and if you came up with the number 8, you're correct. 1, 2, 3, 4, 5, 6, 7, 8. So this lesson is going to be talking about the relationship between these 8 very, very special angles. And I'm not going to get into the vocabulary just yet. I will in a couple slides. First, I just want to talk about the angles. So, if you see here, I have the 4 angles that we talked about in lesson 5A, where 2 lines intersected and we were given 4 angles. And these 4 angles have very special relationships to each other. 1 and 3, they are across from each other. So maybe you remember the vocabulary word for that. Angles that are across from each other are called vertical angles. Angles 2 and 4 are also vertical angles. So what do we know about vertical angles? If angles are across from each other, they're vertical angles, and vertical angles are equal. So angle 1 and angle 3 are equal. Angle 2 and angle 4 are equal. Let me actually grab my highlighter. So angle, well, that's not a highlighter. Here we go. Angle 1 and angle 3 in a different color. Angle 2 and angle 4 are equal. But let's think of the diagram that we just talked about. So let me get rid of this. So now we have these 5, 6, 7, 8. What do you notice about these 4 angles compared to these 4 angles? They are actually exactly the same. Because these 2 lines are parallel, this group of 4 angles is exactly the same as this group of 4 angles. They match up with each other. Do you remember from lesson 5A what it means when angles match up? There's a vocabulary word for that. We used it. We also used it in lesson 4 when we were talking about similar figures. Angles that match up. We'll get into that vocabulary in a little bit. I don't want to overwhelm you yet. Do that later. So which angle matches up with angle 1? Down here. And if you're thinking 5, you're correct, because they are in the same position. 1 is in the top left of this group, and 5 is in the top left of this group. So I can put a yellow dot here, because 1 and 5 match up. Which angle matches up with angle 3? So 3 is in the bottom right. So which angle is in the bottom right in this group of angles? Hopefully you're thinking angle 7. So I can put a yellow dot on 7. But I already knew that 5 and 7 were equal because they are vertical angles. They're across from each other. Which angle matches up with angle 2? That would be the top right one. So the 6 is the top right one. And angle 8 and angle 4 match up. And we knew 6 and 8 were equal because they're also vertical angles. So you could see there's only 2 different colors here. So if I know one of the angles, just one, all I need is one angle, I can figure out all 8 of them. Let's take a look at that. So here's a diagram, and it looks like angle 2 is 124 degrees, which is great. Let me switch back to pen. Okay, so which angle can we figure out without doing any kind of calculation? one of the angles we already know because we know angle 2. And hopefully you are thinking angle 4 is also 124. So which angle did you find first? Angle 4. How did you find it? Because they're vertical angles, you know they're equal. That's the kind of thing that you have to get used to writing and saying to yourself. As your math teachers are going to say it all the time. They're going to say it. But unless you are saying it to yourself in here, you're not going to remember it. So we found angle 4 first because angle 2 and angle 4 are vertical angles and vertical angles are equal. So now how can I find angle 1 or angle 3? Well, if you remember from 5a, when you have a straight line and that semicircle, that means that these two angles add up to 180 degrees. So let me do it over here, 180 minus 124, and I get 56. So angle 1 is 56 degrees. So now I know angle 3, because angle 1 and angle 3 are vertical angles, which means they are equal. So I was given one angle, and I was able to find the other 3. Now, let me get rid of the screen blocker, the screen shade at the bottom. Now I bring that other diagram, parallel lines being intersected by a third line. So if you remember on the last slide, we said that, oh, if we know 1, we know 5. If we know 2, we know 6, because they all match up. And let me show you that. I think I made this so I can actually move it around. Yeah, so I'm going to take these 4 angles, and I'm going to slide them down, and we're going to see if they match up with 5, 6, 7, and 8. So watch the screen. Let me add these in there. There we go. There we go. Ready? Here we go. I'm going to slide. See how I just pulled the angles away? They were here. I took them. I'm going to slide them down, and look at that. They match up exactly spot on. So these 4 angles up here are the same exact as these 4 angles down here, as long as you put the numbers in the right spot. So, because I have the 4 angles at the top, let me switch back to pen. That means I know the 4 angles at the bottom. So since 1 is 56, 5 is 56. Since 2 is 124, 6 is 124. Since 3 is 56, 7 is 56. Since 4 is 124, 8 is 124. So you really only need to know 2 things. Either the angles are equal or they add up to 180. So that's going to be how you find all the missing angles. Now let's talk about all the vocabulary words that connects all these angles. So the first thing is W and Y in this picture, WX and YZ are parallel lines, and there's a third line that is intersecting them. That's line AB. We call that line a transversal. So in the previous slides, when I had the parallel lines and I said I'm going to intersect it with a third line, that third line is called a transversal. That's a line that crosses 2 or more other lines. A transversal of 2 separate lines forms 8 angles, and you can see they're numbered here. They're numbered a little differently than the previous slides. You always have to be careful with the numbers. You can't just memorize them. So 1, 2, 3, 4, 5, 6, 7, 8. The 4 angles that are in between the 2 parallel lines are called interior angles. So here's one parallel line. Here's the other one. Let me grab my highlighter. I guess I'll use like green here. I think that would look okay. So we're talking about in between the 2 parallel lines. That's green. And you can see that would be angles 3, 4, 5, and 6. So we call those interior angles. The exterior angles are the ones that are outside the parallel lines. So that would be 1, 2, 7, and 8. So in the next slide, when we get more specific with the vocabulary, you'll hear us use the words interior angles, exterior angles. Just know that interior refers to in between the parallel lines, and exterior refers to outside the parallel lines. Now, alternate angles are on the opposite side of the transversal. So for example, angles 3 and 6 are alternate because they are diagonally across from each other. And because they are interior angles, we call them alternate interior angles. And the same thing with 4 and 5. 4 and 5 are alternate interior angles. And the special relationship about them is that alternate interior angles are equal. So 3 and 6, 4 and 5 are alternate interior angles. Let me jump on there with the green highlighter. Same thing with the exterior angles. 1 and 8 are diagonally across from each other. They're on the opposite sides of the transversal, so they are alternate exterior angles. And the same thing with 2 and 7. So 1 and 8 and 2 and 7 are alternate exterior. So they are equal. Now, one of the things we talked about on the previous slide and in previous lessons was angles that match up with each other. So we just said that there's a group of 4 angles up here. Oh, I can't use that color. One second. You know what? I'm going to get rid of these interior, exterior highlight stuff because I don't think we need them right now. Alright, let me get my highlighter back out. So we said that there is a group of 4 angles up here and a group of 4 angles down there, and we can match them up with each other. So, for example, angle 1 matches up with angle 5 because they are in the same position. Upper left, and I'm referring to it from this like middle vertex. What do we call angles that match up with each other? It starts with a C. Most students mix up a couple of these words. Angles that match up with each other, angles that are in the same position, are called corresponding angles. So corresponding angles are the ones that match up. So remember, if I took these 4 angles and I slid them down, angle 1 would match up with angle 5, 2 with 6, 3 with 7, and 4 with 8. So that's how I know that 1 and 5 are equal, 2 and 6 are equal, and so forth. Alright, so now let's do some practice and actually get to use the vocabulary. Here's another slide showing all the angles. So you can see here, alternate interior are the interior angles that are diagonally across from each other. So you can see they did green dots and red dots. Vertical angles you already knew. They're the ones that are right across from each other. So again, green and red dots. Alternate exterior are exterior angles that are diagonally across. So look at the dots. Corresponding angles are the ones that match up with each other. So you can see the dots. And then supplementary, again, you already knew. Supplementary angles add up to 180. So the ones that are next to each other and make a straight line in a semicircle are supplementary. So here we go. We need to find all the missing angles. If you want to try this on your own and go ahead, that would be awesome. If not, then you can watch along. We'll do this one together, but that means that you need to practice a couple of these slides on your own. You need to see what you're getting and what you're not getting. So first it says find all the missing angles. So I look at the diagram. I see that this first angle is 40 degrees. And right away I know one of the other angles. Without doing anything, thinking about previous lessons, just looking at the diagram, I know angle C. Why do I know angle C? Look back at your notes. See if you can think of it. Don't wait for me to answer. If you can think of it, that means you know it. And even if you try to think of it and you don't come up with it, that still gets your brain going and it'll help you get there. So I know angle C because these two angles, the 40-degree angle and angle C, are vertical angles. So they are equal. So they are 40. Now I know that the 40-degree angle and the one next to it, the A, create a straight line, that nice semicircle. So they must add up to 180. So 180 minus 40 is 140. So there's that. And I know angle B is 140 because A and B are vertical angles. And then once I know these 4, I just have to slide them down and they match up with their counterparts, which we call corresponding angles. So the first angle and angle D are both the same. They're both 40. A and E are 140. B and F 140 and G 40. Notice again that there's only 2 different numbers here, 40 and 140. So if I give you 2 angles, they're either equal or they add up to 180. That's the only possible situations in this diagram. So when we get to more difficult questions and leading into lesson 6, just know in this diagram, the angles are all either equal or add up to 180. Remember that add up to 180 is supplementary angles. Name all the pairs of vertical angles. So I'm looking at the diagram. I see that A and B are vertical. So A and B. The 40-degree angle in the C. The 40-degree one doesn't have a letter, so I'm just writing 40 degrees in C. And now I look down here, I see D and G are vertical. D and G. And E and F are vertical angles. Why are angles A and F congruent? So I'll just use the pen. Here's angle A. Here's angle F. We can see they're both 140, which is great. But there's a reason that they are equal to each other. What is the vocabulary word that tells us that A and F are equal to each other? Look back if you're not sure, or just try to think of it. It's one of the new ones we learned. Here are the options. Vertical angles, corresponding angles, alternate interior angles, alternate exterior angles. Those are the 4 different relationships that tell us 2 angles are equal to each other. These are not corresponding angles because A is in the top right and F is in the bottom left. So they're not corresponding. They're not alternate interior because they're not interior angles. Interior angles are these 4 in the middle. They're not vertical angles because vertical angles have to be touching and across from each other, which leaves us with the only possible, the only one left, alternate exterior angles. So A and F are alternate exterior angles. All right, moving on. Here's another one. This one, it's the same thing. It's a red dot question because it's kind of like tilted on its side, which makes it a little more challenging. Go pause it, go through it, unpause it. I'll go through it a little quicker than the last one. Really focus on bullet point C down here, coming up with the vocabulary. Make sure you can find all the missing angles, and then make sure you can do the vocabulary at the bottom. Alright, so if you tried it on your own, you are now unpaused and you're listening to me. So I'm going to do it a little differently this time, just to mix it up. So instead of doing the vertical angle first, this angle looks like angle 3 is 142 degrees, and I know that that angle and the one next to it make a semicircle in a straight line, so they must add up to 180. So 180 minus 142 is 38 degrees. So angle 1 is 38 degrees. Once I know angle 1, I know angle 4 because they are vertical angles. And I know angle 2 because that's a vertical angle with 142. Something that students mix up a lot, vertical angles have to be touching. So vertical angles have to be sharing a vertex. They can't be like angle 2 over here and angle 7 way over here. They're not touching. They have a different relationship. Alright, and once we know these 4 angles, I can slide that information over. I can match it up. I can find the pairs of corresponding angles. So angle 5 is 38. Once I know 5, I know 8. And then angle 2 and angle 6 match up. So there's that. And once I know that, I know angle 7. So there's all the missing angles. I'm going to skip B because it's pretty much the same as the last slide. You should be okay with that. C. Why are angles 6 and 7 congruent? Here is 6. Here is 7. They have the same number, so they're clearly congruent. But why are they congruent? Well, they are across from each other. They're touching in the middle. Those are vertical angles. They're congruent because they are vertical. Why are angles 1 and 5 congruent? Here's angle 1. Here's angle 5. And those are both in the same position. So they are corresponding angles. They match up with each other. 1 is on like the left. 5 is on the left. They look exactly the same. They're in the same position. Those are corresponding angles. And why are angles 4 and 5 congruent? Here's 4. Here's 5. They're not vertical because they're not touching. They're not sharing a vertex. They're not corresponding. They're not in the same position. They're not matching up. They are alternate interior angles. Interior angles are the 4 angles in the middle. And since these are diagonally across from each other, they are alternate, I'm going to abbreviate, interior angles. Alright, moving on. So here's this quick mid-lesson summary. I'm just seeing only a couple slides up. We're okay here. Here's a mid-lesson summary. Identify all the pairs of vertical angles, because if you can find the vertical angles, then you already know half of them. And then the second question is how you find the other four. So even if you forget all that vocabulary, as long as you can find the vertical angles and the supplementary angles, you know all of them. So identify all the pairs of vertical angles. That would be, well, pause it, do it, unpause it. Here we go. So at this point, you've now written all this down. 1 and 4, 2 and 3. That's how I write the and symbol. I'm not good at writing the ampersand symbol, so I write it like this. 5 and 8, and 6 and 7. Those are all the angles that are across from each other. 1 and 4, 2 and 3, 5 and 8, 6 and 7. State 2 important facts you know about these angles. 1, they are congruent. Remember, congruent is a word that means equal or the same measure. Angle number 2 is fact number 2 is that they are touching and across from each other. Touching and across from each other. And identify all of, how can you identify supplementary angles in two pair of lines cut by a transversal? Well, there's different ways. I'm going to say 2 ways. 2 ways are they are next to each other. I'll say 3 ways, sorry. They are next to each other. Another word for next to each other in math is adjacent. Hopefully you remembered that word. I know every year there's a bunch of students who don't know that word, and I think that word is used less and less in real life. So then when you get to our class, you're not using it, but that's okay. We're still going to use it in math. Adjacent angles are next to each other. So they're next to each other. For example, angle 1 and angle 2 are next to each other. And look, they make a semicircle and a straight line. Angle 1 and angle 3 are next to each other. Semicircle, straight line. So any 2 angles in this diagram that are next to each other are supplementary. So we just talked about they make that semicircle or straight line. And the third way to tell that they're supplementary is that 1 is acute, meaning less than 90. 1 is obtuse. Now, I will note that not every acute and obtuse angle add up to 180, but in this diagram, they 100% do. So any acute angle and obtuse angle will add up to 180. For example, angle 4 is an acute angle. Angle 4 is acute. So now let's pick a random obtuse angle. How about angle 6? Angle 6 is obtuse. Since one of them is acute and one of them is obtuse, I know that they add up to 180. So angle 4 plus angle 6 equals 180. So those are the 3 ways. Here you go. Find all the missing angles. At this point, I'm going to pause my video. So when you unpause it and when I unpause it, all of the answers are just going to be there. So hopefully you pause it and you really try it at this point. There's only a couple slides left, so please try it. Answers are up. So you can see that all the missing angles were either 153 degrees or 27, because 153 plus 27 is 180. That's where I got those numbers from. I listed all the vertical angles, and at the bottom, angles 6 and 7, they're across from each other, they're touching, they're vertical angles. Angle 1 and 5 are in the same position, they match up, they are corresponding angles. And angles 4 and 5, they are diagonally across from each other, but not touching, and they're both interior, so they're alternate interior angles. Here we go. So what is the measure of angle 7? So pause the video, give it a shot. If at any point I did something that was confusing, either send your teacher a message, ask in the live Google Meet or Zoom session, Google or YouTube it. Please try to take full advantage of this. We're giving you, a minimal amount of work each day so that we can try to stay on top of it. All right, what's the measure of angle 7? So I could find all of them and then just use that, but I don't have to. Since I know this angle, and I'm looking for angle 7, I like to circle the two angles that we're looking at. So you can see I circled them. Those two angles have a relationship. One of the vocabulary words that we looked at. They are both exterior angles, they're on the outside, and since they're diagonally across from each other, they are alternate exterior angles. So that means they are equal. So the answer is choice C. Another way to look at this is this angle is an obtuse angle. It's larger than 90. This angle is an obtuse angle. It's larger than 90. So they both have to be equal. I'm going to get rid of the colors for a second because I'm going to use it again. Why are 3 and 6 congruent? Here's 3, here's 6. Again, I like to circle the two angles that I'm looking at, or highlight. Highlight's a good idea. So they're congruent, but why are they congruent? Are they corresponding? Alternate exterior, alternate interior, vertical. I'm going to cross off C right away because they're not exterior angles. Remember, the 4 angles in the middle and the inside are interior angles. They're not vertical. You guys know vertical angles at this point. Vertical angles have to be touching. So 3 and 2 are vertical. 6 and 7 are vertical. So that's out. Now, are they corresponding? No. Corresponding means in the same position. So I have 4 angles here. I have one that's in the top left, top right, bottom left, bottom right. 3 is in the bottom left. 6 is in the top right. So they are not corresponding. They are alternate interior angles. All right, so fill out the summary, and maybe we'll go over that in the live session. What I will say is lesson 6 is still dealing with all these angle relationships, so you need these vocabulary words. You specifically need vertical angles, supplementary angles, and it would help if you know these vocabularies from this lesson, 5B. So please, please, please study, ask your teachers, work on this. These are things that come up again in 10th grade geometry and again in 11th grade algebra 2 trig. Hope everyone's doing all right, and see you soon.